everyone. Actually, I was going through a report and I saw that there is a scarcity of water all over the world. But how is that possible? Because 71% of Earth is covered with water and only 29% is covered with land. How can there be a scarcity of water? To know the answer of this question, let's start the video with a video title Water Purification Ideas. We know that 71% of Earth is covered with water. But can we use this 71%? No. We cannot use this 71% properly because out of this 71, 63.9% is in ocean and seas, that is salty water. Okay. 5.6% is in Greenland and Antarctica locked up as ice, and the remaining 1.5% is only for us that can be used. So definitely there will be a scarcity of water. But how can we use 63.9% of water that is in ocean and seas? We cannot use that Antarctica and Greenland ice. We cannot use because if we have to use, we have to first melt it, and melting will cause a rise in sea level that will flood the port cities like Mumbai, New York, Amsterdam, etc. So how can we use this 63.9%? There are few techniques to use that. So let's know about these techniques. In this video, we are going to see the techniques by which we can purify seawater. But what is seawater? We should first know that. Actually, seawater is nothing but a complex mixture of 96.5% water, 2.5% salt, and smaller amounts of other substances like inorganic and organic materials, sand, acids, etc. Seawater constitutes a rich source of various chemical elements. Much of the world's magnesium and bromine is recovered from seawater. When desalted this seawater, we get a limitless supply of drinking water. But what is the main composition of seawater? Let's know that. There is chlorine 19.162 gram per liter of seawater, sodium 10.967 gram per liter of seawater, magnesium 1.278 gram per liter of seawater, sulfate 2.690 gram per liter of seawater, calcium 0.4 gram per liter of seawater, potassium 0.39 gram per liter of seawater, carbon almost 0.02 gram per liter of seawater, bromine 0.06 gram per liter of seawater, boron 0.00044 gram per liter of seawater, strontium 0.007 gram per liter of seawater, and fluorine 0.0013 gram per liter of seawater. Now the question arises that how can we separate all these elements from water? Because there are a lot. We have to separate them all to get the drinking water. So how can we? There are two types of impurities in seawater and all the water. Okay. First is insoluble impurities and the second is soluble impurities. Insoluble impurities are those impurities which are not dissolved in water, while soluble impurities are those impurities which are dissolved in water. So first, let's know about how can we separate the insoluble impurities from water. First, let's know about sedimentation and decantation. Sedimentation and decantation is nothing but sedimentation is the settling down of heavier impurities in the water at the bottom of the vessel, and then we have to pour the water very carefully into the another vessel so that the impurities that are settled at bottom don't come in the second vessel. And after we pour the water carefully, we get the clean water. This is known as the sedimentation and decantation. But this is not a good idea at all because many impurities are lighter than water and can come again in the another vessel. Not a good idea. So how can we remove these impurities? So there is a method known as filtration. In that, we used to pass the impure water through a filter from which the impurities remain on the filter paper or filter, and the water goes through it, and then we get the clean water. Now we know how to separate the insoluble impurities. But how can we separate the soluble ones like sugar and salt? And salt is one of the main problems that why we can't use the seawater. So how can we separate the soluble ones? Let's know about it. One of the simplest way to separate soluble impurities from water is evaporation. Evaporation is the process by which water changes from a liquid state to a gas state. And salt can't turn something like that. And if salt can't turn something like that, it remains in the vessel, and then the salt is separated from the water. The second method of separating the soluble impurities from water is distillation. Distillation is nothing but an advanced level of evaporation. In this, we similarly evaporate the water in a vessel. But in this, the vessel is kept closed and a pipe is inserted in the vessel. So the vapor goes in the pipe, and in the pipe there is cold water. And when gas and cold water mixed up, the gas turns back into liquid state, and as it turns into liquid state, so it flows down, and a small dropper is attached at the end of the pipe, and it goes to another vessel, and when it goes to another vessel, all the water is first turned into vapor and again to water, liquid state, and the impurities are left behind in the first vessel.